Hello everyone. I welcome you all to Startup Academy, your online gateway to success in ISS exam. This academy is exclusively for ISS and we have been doing the topic of paper 3 which is sampling techniques. Today will be the last topic on sampling techniques which is interpenetrating subsampling. So what do we mean by interpenetrating subsampling? Suppose if we are talking about a sample which we have taken from a population, if we take out if we divide the sample into smaller subsamples which are independent in nature and estimate the same yield has the same are the estimate the same yield means that the estimation of these sample is equals to the population mean or the sample mean from which we have taken it. So this is known as interpenetrating subsample, and this technique is known as interpenetrating subsampling. So, writing down what is interpenetrating sub-sampling. This is the topic. So we can define it as definition. The statistical technique of taking out, or instead of taking out, we can write it as the statistical technique of that consists of drawing two or more independent sub-samples from a sample using same sampling technique. Same sampling technique here means we are taking out the sample, the same sampling technique. If we have used simple random sample without replacement to take out the sample from the population, then we'll use simple random sample without replacement to take out the sub samples from the sample. Same sampling technique is known as interpenetrating sub-sampling. So this is how we define it. The statistical technique of drawing out two or more independent subsamples from a sample using same sampling technique is known as interpenetrating subsampling. So now we'll just define the estimation variance and estimation of variance, and then the confidence interval as well. So let us consider, let there be G independent subsamples. Let T1, T2, T3 up till Tg be the unbiased estimators of the G sub samples. These be the unbiased estimator of the parameter, sorry, parameter theta. So we are considering the parameter of the population. So these are the unbiased estimator. There is one more thing to interpenetrating subsampling, independent interpenetrating subsamples. So I was telling you that there is one more thing, that these estimators are also unbiased estimator of the population. So hence these are the unbiased estimation of the parameter of the population, which is theta. So where we can say where Tj j goes from 1 to g is based on jth interpenetrating subsample. So the where Tj is the jth value is based on the jth interpenetrating subsample, which we can say is Tj is the unbiased estimator of the parameter theta. So now the unbiased estimator of theta is given by the unbiased estimator of theta is given by, we can write it like that, estimation of theta cap is equals to, we can write it like that, estimation of Tj T bar, which is nothing but theta only. So hence our theta T bar is an unbiased estimator of theta. We know that. Before all of this, let me tell you here, theta cap is nothing but 1 upon g summation j goes from 1 to g tj, which is nothing but t bar. So from here we can derive that. So estimation of theta cap is nothing but equals to estimation of t bar, which is equals to theta. This is what our estimators look like. And about the variance, if we talk about variance of theta cap, it will be nothing but variance of t bar, and variance of t bar has the formula 1 upon g minus 1 into summation j goes from 1 to g tj minus t bar whole square. So this is the formula of our variance. So we can say this is the unbiased estimator of the population parameter indirectly and the sampling parameter theta, and variance of theta cap is nothing but this only. Now we have to prove that the estimation of variance is unbiased estimator of the variance. So estimation, or we can say expectation, both are correct, of variance. If we take expectation of variance, we can write it like that, variance of theta cap, which can be written as estimation of, or expectation of 1 upon g minus 1 summation j goes from 1 to g y tj minus t bar whole square. Now g and g minus 1 can come out. 1 upon g minus 1, expectation of summation j goes from 1 to g tj. Let us add and subtract. Right? So the next step would be rearranging the terms. G minus 1, estimation expectation of summation j goes from 1 to g. First of all, we'll take tj minus theta and then minus t bar minus theta whole square. Moving on the next page, we'll get estimation which we were calculating expectation of variance of theta cap, which is nothing but 1 upon g minus 1, expectation of summation j goes from 1 to g tj minus theta whole square plus summation j goes from 1 to g t bar minus theta whole square. Now here there is no j value here, so we, instead of summation, we can directly write g. So I've written g here. So this is nothing but 1 upon g minus 1. If we take into the estimation, we will be getting variance of t bar here, sorry, summation j goes from 1 to g, variance of tj minus g into, this was minus g into variance of t bar. You can see it clearly. Now we can write it as 1 upon g minus 1 into g square minus g variance of t bar, and this g square and g gets cancelled and we get variance of t bar, which can also be written as variance of theta cap, and hence we can say that variance of theta cap is an unbiased estimator of variance of theta cap. Now if we say that if the distribution is symmetric about mean, which is theta, then what will be the confidence interval? So if the distribution is symmetric about theta, then the confidence interval can be given as probability that minimum of t1 t2 up till tg is less than theta is less than maximum of T1, T2, Tg is equal to 1 minus 1 upon 2 raised to the power g minus 1. This only we have to remember the formula directly. So it is probability of minimum of T1, T2, up till Tg. Theta lies between minimum and maximum of T1, T2, Tj. Should be equal to 1 minus 1 upon 2 g minus 1. So this completes your syllabus of sampling techniques. We'll be doing some questions regarding some PYQs regarding the topics that we have done in this chapter, and after that we'll start with a new topic. And I hope that you have been continuously watching the lecture videos and continuously working harder. And since there is not much time left in the examination, so keep on doing GS and English simultaneously. Vibhuti ma'am's class, idioms and phrases have been conducted on a daily basis. So I would suggest you all to do that on a regular basis. So we have completed the sampling techniques. If you have any doubt in the subject, you can ask in the comment section or on our WhatsApp channel. Your relevant doubts will be answered. All the best. Thank you.